Hello, today we're going to talk about Chapter 6, Discount Cash Flow Valuation. We will first address how to calculate PV, FV for multiple cash flows. Then we move on to talk about special multiple cash flows, annuity, perpetuity. Lastly, different ways of quote interest rate and 3 types of loans. We see multiple cash flow example every day. Investment proposals, saving for retirement, mortgage, auto loan payment, or scholarship fund. The first task today is how to find out the PV of multiple cash flows. We can use formula to discount each cash flow, find out the PV of a single cash flow, and add up. We can also use financial calculators, use cash flow keys to find out the PV of them. Let's first take a look at cash flow keys for PV questions. So all these keys are located in second row of BA2+. Cash flow keys. And you will see the initial cash flows. So I'm going to first clear everything in the cash flow keys. So I'm going to press second and clear work. So cash flow 0 is initial, could be outflow, negative, or 0 or positive. Then you can use the arrow key, go down. This asks you what is the first cash flow. Then where F, frequency, asks how many times we have the same amount of cash flow, how many repeats. After you enter all these cash flows, you press the net present value. We'll ask you to enter the interest rate. And you can use arrow key, move down. Once you see net present value, you are able to compute. So let's take a look of these following examples. There is an investment proposal. The initial requirement is $5,000. Then this will give you 3 positive cash flows in year 1, 2, 3. So the discount is 10%. If we use formula, so we can use 1,000, 2,000, 3,000, discount at 10%. 1 year discount, 2 year discount, and 3 year discount. Now let's practice using cash flow keys. The first, let's press cash flow button. So we enter the 5,000 negative. Press plus and negative to change the sign. Click enter. Remember, you have to enter the number first, then click enter to register. Then move down. The first year cash flow 1,000. Enter down. Second cash flow 2,000. Enter down. So we keep the default frequency of 1 because only repeat 1 time. 30 year cash flow 3,000. Enter down. So that's it. We go to the next button, net present value. Discount is 10. Enter 1, 0, 10. Enter. Go down. Once we see NPV, we're going to click on compute. So we got 184.07. I want you now pause, take a moment to practice this PV question. I want you to try both formula way and financial calculator approach. So that is the first task today, calculating PV for multiple cash flow. There's another type of question. We made a few deposits saving for future, and we want to know how much money we have in the end. So that type is looking for future value of multiple cash flows. Again, we can use the formula. However, for the financial calculators, we don't have a cash flow key shortcut. What we're going to do is, for each single cash flow, we count how many years to compounding and find out future value for single of them, each of them, then add them up. I would suggest you to use the store, recall, calculator keys to store result from each future value. For example, there are 3 deposits, 1,000, 2,000, and 3,000. We want to know if the account offers you 10%, how much total money you will have by the end of year 3. So let's first look at how many years compounding, how many years interest payment we are receiving. For the first cash flow, which you deposit by the end of year 1, there are 2 more year interest payment before year 3. For the second year cash flow, there are 1 more year compounding, 1 more year interest payment, while the last cash flow we deposit at the end of year 3, so we don't earn any interest payment. So what we're going to do is we're going to use formula, compounding 10% for 2 more year, 1 more year, and itself, or we can use the financial calculator keys. So let's try that. So the first cash flow, we save for 2 years. Let's first clear everything, clear time value money. The first cash flow, 2 years, we have 10%. And the initial cash flow is 1,000. I put a negative for sign convention. Then compute FV, right? So I'm going to use store recall function, put result into these 1, 2, 3, 4 keys. So I'm put STO store into key 1. Then I move on to the second cash flow, which is 2,000 to save for 1 more year. So N is 1, IY against 10, PV is 2,000 negative. Then I'm going to compute FV, right? Okay, again, I'm going to store into another key, store into 2. So we're going to add now 3 result, 3,000 itself, the 30-year cash flow, result from first calculation and the second calculation. So I'm going to add 3,000 plus recall result from 1. Then add recall result from 2. The total is $6,410. So I would like you to practice, find out future value for this multiple cash flows. So this concludes how to look for PV and FV for multiple cash flows. As you see, these cash flow from year to year, they are not necessarily the same amount. They could have very different amount. Now, next, we're going to talk about special cash flows, where every period, the amount is the same. So the first type, special cash flow, is called perpetuity, where the same amount is paid or received every period, and this lasts forever. The common example is preferred stock or university endowment. They set up fund, use the annual interest payment to offer scholarship and so on and so forth. To solve this type of perpetuity, we actually only use formula. So the value of this type of a cash flow is the cash flow, periodic cash flow amount payment over discount rate. Let's look at one example here. Perpetuity for preferred stock. The preferred stock pays a quarterly dividend of 7% based on the par value of 100. The required rate of return is 20%. What's the value of this preferred stock? Use formula. Every quarter, the company pays $7, 100 times $7 preferred stock, required rate of return 20%. So this gives us the value of this preferred stock should be $35 per share. Perpetuity can be also used to evaluate endowment scholarship fund. Suppose there is a potential donor want to find out, give money, set up a scholarship fund. Every year, this fund uses the annual interest payment to pay out 10 scholarships, each worth $1,500. So how much initial money should you put into this fund? Again, this is a perpetuity example. I will ask you, use a calculator, find out. The answer is 300,000. So perpetuity is the same payment and continue forever. There's another type of special multiple cash flow, which is annuity, where the same amount is paid or received every period, but for a couple of periods. We see this all the time. We see the mortgage payment, auto loan payment. We see the deposit for retirement, saving for college educations. So there's a two types. For the loan question, you borrow first, then pay back later. For the retirement question, you save first, you want to reach a goal in the end. So we call this annuity PV question and annuity future value question. The formula for annuities, for PV, it is the same amount, annuity payment times the PVIFA, this annuity present value interest factor. And for the future value, you can also use a factor, annuity future value interest factor, or you can use original formula. For the calculator, we will still use the third row in the BA2 plus, where among the 5 keys, we only actually use 4 of them to solve for a PV or FV question. So just pause a moment every time, ask yourself, are we solving for long question or saving question? The sign convention still hold, which means you cannot have all the value positive. One of the values should be negative. Let me talk about annuity factor. This is used very, very popular in practice. So some of the commonly used annuity factor are listed in the appendix A3, A4 table, but you can calculate by your own for any special kind. For example, annuity present value interest factor at 10%, 3 years. According to appendix 8.3, this is 2.4869. But you can do this by yourself. Use calculator. Let's find out annuity factor. Use calculator. Okay. First, clear time value money. I enter 3 into N, 10 into IY. Then I put 1, negative 1 into payment. Then compute PV. So I get 2.49 because I have 2 decimals. I can change decimal into 4 and reduce this. But you get this idea. Let's do one practice. Suppose you're considering buy a new car. You know how much you can afford every month. You can afford up to $632 a month. The bank quotes you a loan, 12% interest rate compounding monthly. You're going to pay off in the next 4 years. So how much you can borrow today? So this is a long question. Borrow first, pay back later. A note of caution is regarding interest rate. The bank always quotes you annual rate, APR, 12%, but you are paying monthly cash flow. So to do this, you have to convert annual rate to the monthly rate for your calculation. So in other words, here we use monthly 1%, we use 48 months. Use the financial calculator, we will put 48 into N, 1% 1 into IY. So let's try. Second, clear everything. So I'm going to this time, okay, N to 48 into N. The rate is 12 divided by 12, which is 1%. I put into IY. Then monthly payment is 632 negative into payment. This is signed conventionally. Then I'm compute how much I borrowed today. That's PV question, PV. Okay, so I got it. Another example. Suppose you are able to borrow 20,000 for a new car. Bank offer you 8% annual rate. If you take a 4-year loan, how much is your monthly payment? Very similar, right? So again, to do some preparations, make sure we use monthly interest rate. Okay, make sure we count the number of months, number of payment, 48 instead of 4 years. So let's try again. Let's say clear everything. So I'm going to put 4 years times 12, which is 48 into N. I'm use 8 divided by 12 to get the monthly rate IY. Then I borrow 20,000, put into PV, then compute payment, right, for 488.26. Okay, so I want to pause a moment and practice these two questions. In practice, we sometimes want to find out how much money we could have if we saving for retirement. So that's a saving for retirement question. It is a type of looking for future value for annuity. For example, you are saving for retirement. Every year you deposit 2,000. The account gives you 7.5% compounding rate. How much will you have in 40 years? So we can use the formula or calculator. Okay. So again, I'm going to clear all my numbers. Okay, so I save for 40 years. The rate is 7.5. Then every year I put negative. I put 2,000 into retirement fund, which is repeating the payment. Then I'm compute for how much money in the end is future value question. So I have 54,513. Another example. Suppose you are able to borrow 20,000 at 9% compound monthly rate. You pay for $97.71 a month. So how long do you have to wait until you pay off the loan? So just looking for the number of payments question, ask yourself, is this annuity PV question or future value question? Remember, if we borrow first for loan question, it's PV question. If we saving for retirement, that's future value question. So in this case, we borrow first, pay back later. Loan question, that's PV question. Let's again clear time value money. So the N, we are looking for N. So start with the rate, 9%. Annual rate divided by 12. So that's interest rate. Then we borrow 20,000. I put negative in front PV. Then monthly you pay 497.71. So that's our monthly payment. This question we are solving for the period. So it's 48 months. right? Remember, so if we ask how many years, we divide by 12 months, it's 4 years. So I'm going to ask you now, pause a moment, to do more annuity practice. I'm going to talk about annuity due. So in real life, when you sign up a mortgage payment or sign up a lease contract, the first payment normally due today, the time you sign up the contract. So this is the cash flow paying at the beginning of the period. We call this type of annuity called annuity due. So in the formula, all you need to do is adjust by 1 plus the interest rate. For the calculator, we have to use second begin, second set to change into annuity due calculation. The rest is the same step. For example, you're saving for a house, you deposit $10,000 every year. Account give you 8%. The first payment is made today. So you want to know how much would you have at end of year 3. So a 3-year annuity question, but start with annuity, the beginning of the period. For the regular formula, all you need to do is adjust by 1.08. For the calculator, you want to set begin. Okay, so how do we display the begin in the calculator? So you go to the calculator, press second, on top of the payment key, you see BGN begin. Press second. Press payment. You see by default this set into end. So I'm going to use a second set. Second. Okay, on top of end to set. You see now I'm changing into begin. So you see the BGN is displayed on top of your screen. Even you turn off your calculator, it's still in this begin mode. Let's do now this question again. Clear everything, clear time value money. 3 into N, IY is 8%. Then we have 10,000 into payment, then compute FV. Okay. Here is a practice for you to try your second set. A word of caution, after this calculation, you need to change your begin back to end. So we're going to again repeat same procedure. Second payment, now then second set. Okay, so now begin is no longer displayed. We want to now take a moment to talk about interest rate. As you know this, we mentioned the APR a lot of time. So the APR annual percent rate is a quoted rate. By law, all these institutions, banks, they need to give you a quoted rate, APR, even though your actual payment could be monthly. For example, you have a 30-year, 6% mortgage. The APR is 6%. But the monthly rate is maybe 0.5%. So if you know monthly rate, you can convert APR by multiple the number of compounding frequency. Now we're going to talk about effective annual rate, EAR. So this is not displayed or communicated to the investors. So this actually rate will help us to compare different type of products, loans, line of credit, in different investment choices. So you can think of a bank wants something, tools to compare different instruments. How do we convert APR to EAR or another way around? You can use the formula where M means number of compound frequency. In the BA2 Plus, we can use a calculator I convert, so which is on top of the key number 2. Okay, so let's see. Press second, press I convert. So you will see norm, EFF, or CY. So here norm is equivalent to APR, the annual rate, APR, while EFF is the equivalent to effective annual rate, while the CY means compound frequency M. Let's see if bank have two APR. One is 5.25 daily compounding, the other is 5.3 semi-annual compounding. So we want to compare which one actually is better, which one is higher. So we need to convert the ER for us to compare on the same ground. Okay, so this is the formula approach. For the calculator, let's try the first one. I press here second and I convert. In this case, 5.25 is the norm, APR, so I enter 5.25, enter, then go down. I have to enter, which is daily frequency, 365, enter. Go down, we see EFF, run compute. So we got 5.39. Same thing, you can do this for the second offering. Sometimes investors are assuming compounding, non-stopping compounding. So in this case, we will use natural E or log to find out APR or ER. A shortcut, if you are using financial calculator, as usual, it's going to set the compound frequency to a very big number, like 99999. That will do the trick. Example, if bank want to compare two loans, they want to both of them have the same ER of 12%. So what APR should we set? One is semi-annual, one monthly. So I'm just display one calculator for the first one. So here, the 12% ER, we're looking for the APR norm. So again, I press second, I convert, and I'm going to clear the work. Okay, so here EFF is set at 12, enter. The frequency is, for the first one, is semi-annual, so enter 2. Then we compute. We got 11.66, right? Repeat same procedure for the second account. Here I want you to practice. I have a few different loans. Some are quoted at APR, some are ER with different frequency. So here's the solutions, answers. I want to use the financial calculator to find out the missing ones. So let's remember, when we solve multiple cash flow questions, when we have annual frequency, you have to use annual rate. When the cash flow paid a monthly, you have to use monthly rate. For example, here is example. Deposit $50 a month, and this account has APR of 9%, compound monthly. So how much money would you have in account in 35 years? What's the ER effective rate? So remember, everything's monthly. Payment month $50 repeating. APR 9%, have to divide by 12 to get monthly rate. Okay, 35 years, have to multiply by 12 to get the number of months. Right? So in this case, okay, monthly rate is 0.075, number of months 420, and then we compute for 50. For the effective annual rate, we convert 9% APR to EAR. Lastly, I'm going to talk about type of loans. They are pure discount loans, interest rate loans, or amortized loans. Pure discount loan with no interest payment or principal is ever paid until maturity date, while interest-only loans pay every period interest payment, and the principal will pay off in the end, just like the bond, corporate bond. For Amortized loans every period, both interest payment and principal is paid, but sometimes principal is paid on the constant same amount. But like in the case of mortgage or loan payment, auto loan payment, total payment is the same, while the interest component and principal repayment are changing every single period. So chapter 6, we talked about a lot of things. PV, FV for multiple cash flows, annuity, perpetuity, interest rate quotes, are 3 types of loans. So that's all for today.